Hello, I'm Bradley Sward, an Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video is going to take a look at creating our own custom version of a linked list structure in the C++ programming language. So I already have a few videos set up, so if you're interested in the standard template library version and how all the functionality of that works, go to that video. And I also have a high-level understanding video of what a linked list is. This is neither of those things. We're just going to jump right into creating a linked list just pretty much right out of thin air. So here I already have going for me a blank Visual Studio project that I'm going to start up. And so the first thing I want to get a hold of is just like a main. So new source.cpp, just to kind of get something going. I know I'm going to need to include IOStream at some point. I can do my using namespace. Just forget that. I'll just use int main, return 0. And what I would love to be able to do, right, since I'm creating a linked list class, is I would love to be able to say, give me a linked list, and I'll call it A. Something like that, right? And so that's the first part, like, okay, I would love to be able to start that. But before we can even start thinking of a linked list, going back to these lectures, we have to think about a linked list node, which is basically the data structures that are being managed. And again, think of every link, every element in our chain here, as since we're going to be doing a doubly linked list, having a pointer to its next element and a pointer to its previous element. And so it also stores data. So let's kind of just jump right into doing the node class, which is relatively simple. And you'll see this, and I'm going to make it a little more complex than you see in the PowerPoints. But I am going to go ahead and create a, come on, I really am. I'm going to create a linked list node class, .h header file. So class linked list node. Okay, so you can actually, let me just say, you can start it out as a struct. And so the main difference in C++ versus C of struct versus class is by default struct, everything is public, and everything is private by default in a class. So I want to set this up, and there's three elements I need to keep track of. I need to keep track of a pointer to the previous node. I'll also need a pointer to the next node. And I will also need to keep track of data. I'm just going to keep track of it as an int. I'll call it data. And so I have three pieces of data I need to keep track of. And according to the lecture notes, this would be all we need. But because I know what's coming ahead and trying to make our code a little simpler on the other end of this thing, I am going to create a constructor. And I'm going to pass along, a value. I'm going to pass along a linked list node pointer to the next, or sorry, to the previous. And I'm actually going to say, use a default parameter here and say null pointer. And so again, the whole point of this is to make our life a little bit easier. So linked list node pointer next equals null pointer. So when I do this kind of stuff, sometimes I like to break things up just because after a while you're like, oh my goodness, this gets really complex. And if I can break up each parameter onto a line, everybody's a little happier. Put a semicolon here. And so again, I can create this as a struct, or if I want to, this is probably more up most people's alley here, I can say class, but then I have to make this public. It doesn't much matter. Okay, and then IntelliSense and all the formatting and all that hard work of mine goes right out the window. But okay, so the only thing we have to implement here is the constructor. So I can go ahead and do that and go over here and say, okay, here are my things. And so just like everything else, what do? I say, okay, my data is the same as value, and my let me just come back. Let me just move this over so we can see it. All right. So maybe I'll use a capital D here. Keep everything capital letters here. So capital D data is equal to value coming in. Previous with a capital is equal to previous with the lowercase. And this is where it gets tricky sometimes because I have a knack for completely butchering naming of things, but that is what it is. And so there are the three parameters, and then there's nothing going on in the main body of the constructor. This is just setting everything up. And so what's cool about this is I can actually pass this along with one parameter, 2, or 3, and then the nulls, the null pointers will fill in if I neglect anything along the way. And again, it's just to make things a little simpler on the code side. So I have my linked list node. That's it. That's all there is to this. If you ever wanted to add more data to this, you could, but there's really nothing we have to really worry about. So now moving on. So now coming back here, like I still haven't done any real work to get to the actual linked list part of this. And so now I can go ahead and start this thing up. And so this is the linked list part, linked list.h. Okay, so class linked list. We will definitely need to include the linked list node.h. Public private. And what's interesting about this is the only thing we're going to store under the hood, because we're used to vectors, we're used to all these other kind of data structures. It's like because of the way the data structures and all the elements are going to be set up dynamically in memory, we only have to start out with a linked list node pointer to the head. That's it. It's crazy to think about. There's no arrays, there's no this, there's no that. It's just one pointer that points to the head. And so if we've got this, and so just to get going here, I want to have just a basic linked list constructor, just a default constructor that doesn't pass anything along. And so I'll define that just so I can get the CPP file going. Oops, come on, where's my CPP file? There it goes, bring it over here so we can kind of take a look. And so the only thing we're going to set aside here is just say when I create any of these linked list objects, head will be equal to null pointer, because that's an empty, list. And so with just these two little, this little bit here, I can go back to source. And now as long as I include linked list.h, did I actually spell it with a capital I? Oh, man. Oh, well, we'll leave it for now. That's no big deal. That's just stupid typing. Okay, so where's my source? Okay, so now we can come back, and now if I run my program, everything compiles, everybody's happy. My A has a head that has a null pointer. So everybody, up to the moment, we are perfectly legitimately running code, running our own linked list class. And so you can go ahead, and if you wanted to, go ahead and run this F11 and go in and see, yep, I am inside the constructor. Okay, so now it's just a matter of continuing on and adding some more code, and it gets a little more complicated, of course, because I have this here. Like, what do I have right now? Don't mind the stuff down here, but what do I have now? I have a head pointer pointing to null pointer, and that is the entirety of my data structure. So, okay, so we're gonna need a destructor, and we'll have it, I'll fill it in later, because the tricky part here is there's going to be a lot of iterating through our data structure, trying to find the last node, or just trying to go through every node. So it's, but once we are used to that, there's really nothing overly complex about anything we're going to do. So that I won't leave this, but we will fill this in a little bit. But I would say, like, the first thing I would want to do with this is to be able to put some data into this thing, and then print out to make sure, that my data structure holds data in a way that I anticipate it being true. So I have my linked list, I have my linked list destructor. So now I'm going to create a function called pushback, and I'll pass in a value using int data type. Okay, so I'll define this. So now what's tricky about this is, at least the way we're setting things up, we don't have what's called a dummy node. This is just we're just using the head pointer to start out with this thing. So because of that, there's two different ways we could push to the back of this data structure. And one is the first way here. If there's nothing in my data structure, if this thing is completely empty, then I will handle things one way. And then when there is at least one element in here, I will handle things a slightly different way. So over here in my pushback function, because what I would love to be able to do is to say here a.pushback, and let's put a 1 in there, and then just keep on going, right? Push a 1, push a 2, and then I would love also to be able to just do, hey, I want to print print the whole linked list out. So this is where I'm kind of going with this. I'm going to comment this out and bring it back in a little bit. But push back, and then print, that's what I would love to be able to do. So just as such here, if I'm in the pushback function and I want to add to this, I need to new up memory no matter what. So at least right now, let's just like, this is the empty case. Their size is 0 case. Okay, so let's see, if let's see, head is equal to null pointer. Sorry, let me bring back the actual thing here. If head, capital H, is equal to null pointer, then you know you have an empty list. So what do I want to do? I want to say head is equal to new. Let me just open up my thing over here, make sure I do this exactly how I'm supposed to. And I say linked list node. Give me a new node and put the value in there. So head is going to be equal to that. And what does that mean? Let me see if I can bring this over here. Put the .h. Let's switch it up because we're going to use this a little bit more. So let me bring up Excel. So what does that mean here? So instead of this head pointing to null pointer, I'm going to go ahead and create a new data structure, put a value in there, just put a 1 in there, whatever we're doing. And then when it comes to linkages, because we didn't supply anything else, we're going to say, okay, now this goes to null pointer, because those are the defaults, right? Remember? And then there's a return that goes to null pointer. There's no reason for it to go to head. So let me just go ahead and just bring this up a little bit to like this and just say, okay, that's null pointer. Because there's no reason for this to point back to the head. This is the first element in the list, so if I wanted to go backwards, I'm going to null pointer. And right now, since it's the only one, if I go forwards, it takes me to the same place. So that's what happens in this first case if I have a 1. So I can run this, and you can kind of see, maybe we can, let's see. Where's my source.cpp code? It's like, oops, let me run this through here. So you can see I can go in here and say, okay, head was null pointer a second ago. Well, head is now equal to something here. Previous is 0, next is 0, null, null, and the data value stored inside of here is 1. And so you could say like, well, why do I need this extra special case? Why am I going to have to fix this up? And the reason is very quickly here. If I go into this one more time, head is pointing to an object that has a 1. But I'm like, oh, well, right now it won't do anything because of this if head equals null pointer thing. It'll come right through. The value will never get pushed into the data structure. So basically, I can't do anything with this thing. It's only going to have a size of 1 forevermore. So I have to go ahead and have a completely different way of doing things here. And so this is our first time thinking about progressing through and traversing a list, because the whole point of this push back is I need to find the last element in here so that I can go ahead and add to it. So what I can do here is I can set up a pointer, linked list node pointer, and I call it current. And I'll say it's equal to head. So now I have 2 pointers pointing to the same place. I have current pointing to wherever head is pointing. So current is pointing to the 1 here, if you want to think of it that way. And now I can say while there's something to go to, while current arrow next does not equal null pointer, what am I going to do? I'm essentially just going to keep running the chain out. Current equals current arrow next. Just keep on going, keep on going, keep on going. So in this case, when we're adding the 2 to the list I already talked about, this current's next pointer is pointing to null pointer, so this will never even do anything with the while loop, and current will still be pointing to the element that is the 1. Because now what I want to do is go ahead and set up the linkages on this new node and say, okay, so now we need a temporary pointer. Well, I guess we don't necessarily have to have a temporary pointer, but linked list, and we can always fix this up later, linked list node pointer temp, oops, come on, equals new linked list node. And so the value is the value, of course, and now for this guy, this new one, right, because I'm newing up something, I'm newing up a guy right here in its place here, and I'm at, okay, value is going to be 2 in here, and we need to set up 3 linkages in total. 2 for this guy and 1 for this one, because this no longer is pointing, this is still pointing to null pointer. We need to get this guy to point to here, and this to point to here, and this to point to null. So when I'm creating this new node, I'm putting the value in, and then the next parameter is what's the previous. And the previous at this point is current. Because as we discussed, this current is pointing to this guy right here. And so if I say, okay, your previous is this one, why did I get rid of that? So now the 2 will be pointing to 1. And then because I don't supply anything else after that, the null pointer gets put into its place. So this will also be now pointing to null pointer. And so the last thing to set up here is what do we do with currents next? Because a moment ago that was pointing to null, and now if I forget this line of code, all these linkages will never get set up right. Currents next is equal to 10. And that's it for pushing back, because it's the only 2 cases there can be. It can be empty or not empty. And in this case now, I'm setting up the final linkage so that this guy can go to this guy can come back, and then this goes to null. So this would be the empty case, and this would be the non-empty case. Okay, so that basically handles all pushback, and you go, yep, do you believe me? I never believe me. I'm right. I'm a programmer. My goodness, right? So the next thing I would want to do is go ahead and create a way to print everything out. So I'm going to steal this just so I can write it out perfectly fine. Give you a moment to look at this. Where's my linklist.h? So I'm going to add the operator for print, and of course the real one, the standard template library, does not have this. I'll have to include IOstream. So come on, there we go. So it's going to implement the chevron operator for print out. So stream on the left-hand side, linked list of constant reference on the right-hand side. So I can go ahead and implement this, set that up. And so again, we've traversing the linked list. Once you understand how it works, it just gets pretty darn boring here. So it's just a matter of just going through, and we just return my oster. And just say, and it's just a while loop. And I usually, just for the sake of this, I usually print an X, at least to start out, just to make sure it's doing everything correctly. I print an X, and then I print it at the beginning and the end of this. So if it's printing out a blank, empty linked list, that I actually know it's actually printing something, that's actually getting in there and doing the work. So this is a while loop, but I still have to set up a linked list node pointer. Set current equals head. While, and now this time's a little different. Well, current itself does not equal null pointer, not the next. I mean the current one. Oh yeah, RHS.head, because this is not a global function, and I have friend access to the head pointer, so I can go ahead now and say, okay, while current does not equal null pointer, I can print out the current, or sorry, let's see, this is the fun of this here, current data, and then I'll just add a space just for the sake of it, and then I have to make sure I say current equals current's next. So let's try that out, and let me come back to source here. Let me comment this back in and put these in a few places here. Empty list, one size list, two size list. What prints out? And so bringing over XX, there's nothing, so X is, X to start, X to end. There's a 1 between there after I added the 1, and then there's a 1, 2 after I added the 2. So, and if you really wanted to, go ahead and just try it a few more times. I'm not going to loop it. I'm not going to spend the time, but 1, 2, 3, 4. Print everything out. Oh, do I have a breakpoint? What did I do? Hold on. What did I do? Uh-oh. What did I do? Okay. Interesting. I have an infinite loop going on. Wasn't going on a second ago. Print out X, current equals, print out the X. What is happening? Nope. Now it's working? I don't know. Programming is a fun thing, right? There. Okay. I did absolutely nothing different. There's my 1, there's my 2, and then there's my 1, 2, 3, 4. Okay, so, okay, back on track. Oh boy. Okay, so I have my print function all completed. So there you go. And if you're happy with it, you can kind of remove those prints. Okay, so what have I got done here? I've got done constructor, I've got done pushback, and I've got done the operator for printing everything out to the screen. So nothing, 1, 2, 3, 4. Okay, good. All right, so moving on. I'm only going to do a few more of these because the homework assignment for this will be to kind of complete everything. So let's see. If we've got a pushback, how about we do the pop back? That's the last difficult one of all of these. And so void, I can do this on this side here, void pop back. Implement, please. Okay, so just like pushing back, we'll say, okay, add to the back of this linked list, the final element, add a new one to that. This is going to take off the one just the same here. So this one's a little tricky. That's why I'm doing this as the last part, and then everything else kind of clears up here. But it's just a matter of, well, what do I do? How do I, how many different situations can there be if I try to pop the back element? And so the easy one would be, what if there were no elements at all? I tried to pop an empty list. Well, how about that? Let me get rid of this. Okay, like, oopsie. Yeah, I should throw an exception because you're trying to pop an empty list. Exactly that, right? So throw an exception out of range, which is tied into the exception, like the true std : exception. So we got that going for us. So this is an empty list. And so just kind of thinking ahead and just thinking things out, like there's actually 3 situations here. And I don't need to put an else because I have the throw. But then there's also, well, what happens if there's only one element in here? So that's this case where you say, okay, head's null pointer, throw an exception. But what if there's only one element? Because again, remember, I have all these doubly linked little cartridges flying around, pointing to one another. So it's a matter of, if it's only one linkage, there's nothing. If I want to go back and change the one before me, I can't really, because then I'm going to crash, because I'm going to go to the previous, which is null pointer, and then say, let's affect your next pointer, and things are going to break. So when this works out, I just have to go ahead and delete the head pointer. This is weird, right? Because you're deleting the head pointer, but it's fine as long as I remember, I put it back to null pointer when I'm done. And so coming back here, what does that mean? If this thing was pointing to just one element, which is head is pointing to one element, so I'm deleting this memory altogether. So head is pointing is a dangling pointer at this point, pointing to a memory location that has been given back to the operating system. And then I'm saying, okay, now you're pointing to null pointer. So that's perfectly fine for that case. So this is the size 1 case. And so that's case 2, but then otherwise, the else of this is everything else is a one size fit all. Size 2 or more case. And so just like before now, what has to happen is I have to find basically the last node so that I can delete it, but then I also have to make sure that whatever was previously pointing to it, and I'm guaranteed there will be because there's at least a node before it because there's 2 nodes or more in my list, take that, what was currently pointing to current, and then now basically point that to a null pointer instead. So we've already done the case here. We have to get a linked list node pointer current equals next. I'm sorry, head equals head while, and so I have to keep finding, but I need to find the one. I have to keep on going until I can say, okay, while the next is not a null pointer. So I have to keep on going. So I'm like looking back here and you go, okay, here's my 1, here's my 2. I want to make sure I'm deleting this pointer here. So I have to make sure when this is my current and I go, hey, what's your next null pointer? I don't continue on, because if I continued on one more time, I'd get to null pointer. And then there's no way to get back from that. I can't go, or because it's pointing to nothing. I can't get any of my linkages. So I have to say, while whatever I'm currently pointing to, while I can continue on, keep on continuing on. Current equals current dot or arrow next. Okay, so, and then so when it's all said and done, current is going to point to the to object here, the to. And so what I want to do then, of course, I'm going to delete this object, but I got to make sure before I do any of that that I basically fix up the linkages. And I don't care about the linkages of this guy because I'm going to be deleting it. So like this linkage can go away, this can go away. It has no bearing on anything, but this one better go point to the null pointer now. So this would go away, null pointer, oops, null pointer would come on over. So the final steps here is to say, okay, current, and this is where things get a little funny here. Hey, current, your pointer to previous, which is, oops, we're coming back here. So let me just undo this for a second here. Okay, so hey, your previous node, and now I'm pointing to the 1, and then I say, oh, hey, 1, your next node is now equal to null pointer. So yes, you can do this. You can chain linkages together. Take a pointer, bring it back, and then take it and now set the next to null. And then now everything is safe to delete the current pointer. So what am I doing here? I'm saying, okay, hey, this is my current. I go, hey, your previous nexts, this guy right here, you're now pointing to null pointer. Okay, and now this too, I'm deleting everything, and with that, the pointers come along too. So now, and that's it. And so the next time through, actually because head's next is pointing to null pointer, I would erase the 1. And so and then it would replace delete head. So I delete this 1 out of the way and then say, okay, head, now you're pointing to null pointer. And then when I try one more time, I go crash because now it's a null pointer. The head is pointing to nothing. The list is completely empty. So I can say, I'll just try this, since there's 4 elements, I could try this 4 times. For int I equals 1, I is less than or equal to 5, plus I, a dot pop back, and then see out the whole thing with the end line. And let me get rid of now we don't care about these anymore. Okay, and I'll try 5 times because then we'll hit the exception. Oh, maybe I should print before maybe just for the sake of making this a little more clear. We did hit the exception for sure. I'll print everything out and then do the pop back. So there's the crash like I was promising. So what have I got? Printing out the full list, then the 3-element list, then the 2-element list, then the 1, and then the crash. So let's try it. Let's just, oops, so just keep running it, Brad. Why don't we keep doing the pop back? Okay, so when there's 4 elements and I try the pop back, it goes in to this one and while, and delete. And that's what we expect. Now it'll print out the 3-size list. So there we go there. So then I try going again. So there's still 2 or more. So it goes in down here into the size 2 or more, does the same stuff, goes through 1 less time because there's 1 less element, changes everything up like we were talking about previous, print it out, and now we're talking about there's only 2 elements remaining. And so now here we go. Here's the 2 or more. This is the final time we talk about this. Go in here, handle it 1 more time, delete everything, change everything up. So now we have 1 element remaining. And so now this pushes us into that new part of the if statement that does the work, because head's next is now going to be null pointer. And because of that, I can delete head and I can say head is null pointer, fall back out of this, print out my empty list. And it did print an empty list. We don't have those X's anymore. But now, as we see here, head is pointing to null pointer. Our head is pointing to null pointer, so I'm going to throw that exception. And there's nothing to catch it because I didn't do anything over here, but I can totally go ahead and try and do my try catch block, right? And that's the whole point of this, is if something goes wrong, it's up to me to handle what I would want to do with it, and I'm just going to let it silently fail because I'm just trying to make a point. Or I could do I could just print out exception caught. Or, oh, like I said, I could do print out e dot what. And let's see what happens. So now it doesn't crash. Now it doesn't crash anymore. There it is. And so 1, 2, 3, 4, 1, 2, 3, 1, 2, 1, empty, but it printed it out the empty before I did. And there's my tried to pop empty linked list. That's e dot what. And the exception was caught. The program did not crash, and everybody's happy. Okay, so that handles pop back. That's pretty much, you know, say the 0 case, the 1 case, and the 2+ case. Okay, so let's take a look at just a few others. Just like in other, you know, a lot of these data structures, I can get the first element, I can get the last element. So I'm going to set up 2 little functions here real quick. I know we're a half hour in, but we got about 5 or 6 minutes left to go here. Maybe a minute or 2 more. I'm going to get the front element, and I'm going to get the back element. I'm going to return it as a value type. The true standard template library functions return them as reference types, but we're not going to deal with that. Okay, so what do I do, right? So go to definition, create them, create the definitions, find them, here we go. So front, this one is, you know, so again, coming back to the thinking with exception handling now, like I have to understand that if I do this kind of thing, if I'm trying to get the first element of an empty list, or if I'm trying to get the first element or the back element of an empty list, I did something wrong. So in this case, I tried to call back on an empty front on an empty linked list, tried to call front on an empty linked list. So that is the exception that can get handled here. But the front, otherwise, if it falls through that, then otherwise the front is very easy, because it's just get me the data of the first element, and you already promised there'd be something there. So I know head is pointing to something, at least in the front case, and I can just say, okay, give me the data that head is pointing to. That one is kicked off and done. And so the back is a little more complicated, but we've already done it. Where's my back here? So it's just stealing this while loop, because I need to find the final element for back. Oops, that's why I couldn't find it. There it goes. So I have to go in the current, and I got to steal the null pointer, the current, copy paste. Okay, so then if that's all there is to it, this will get me the final node, and then I can, instead of returning, and make sure you do the return outside of the while loop, because otherwise it'll just return the first element, just like basically it'll return a front. I will return current's data. So in this case, if I wanted to, just to try it out, here we go. Let me get. So we did the pop back, so I'll get rid of it. So let's see. I have 1, 2, 3, 4 here. Let's see out a dot front. Maybe I lied about 6, 7 minutes. Sorry, guys. And then a dot back. And so this should print out the 1 and the 4. Oops, let me fix that. Dangling thing guy there. Whoops. And what did I do wrong? Oh, what am I doing? Oh, I stole it from the wrong place. I stole the print. Does that fix anything up? Nope. Oh, in my head, oh boy, sorry. If I wasn't half an hour in, I would start over. I just copy pasted the wrong thing. What do you know? I'm just like everybody else. I want to make sure that as long as the next pointer, because that was, oh man, some of you are probably already caught it. You're like, oh, what a dumbass. But I'm like, I need to make sure I get the node that is the last node. And if I was just checking current, not checking current's next, I would get to the null pointer. And then when I would try to access it, it would break on me. Oh boy, sorry about that. So wish I could just go back and revise that, but I'm not going to. But there you go. There's my 1 and my 4, because now the front, as long as there's at least one element, will give me the head's data. And now with this case, if it's not empty, it'll go and go and go until it finds the element whose next pointer is pointing to null. And then when that is all said and done now, I can say, okay, that's the last one, give me your data, and return that thing back. All right, semi-embarrassment, happens all the time. Okay, so that is the end of that. And so now one easy one is a function called empty, just a bool function. And is this thing empty? Basically, what is the size of this thing, 0 versus non-zero, right? So really all there is to it here is you're just going to say, hey, is my head null? And if it is, then it's empty, right? There's really not much to it there. Let me just make sure I have the right. If head is null pointer, because if head is null, then there's no elements. But if head is not null, then it's not empty. So that's a one-liner, right? So this is just returns. This is a whatchamacallit here. This is just a bool statement that gets returned. All right, so that's easy. So now the final thing I'm going to do for this video is I'm going to be able to clear all the data and then hit the destructor, because I talked about this, alluded to this over a half hour ago, and then now, and we both can use the same thing. So actually, if you want to think of this, I can call clear, and that would be it. Because if the clear function does its job, the linked list will erase all of its own data, and it'll be totally perfectly fine. So just saying like, okay, that's it for that. Well, how about we add the function for clear then, right? Okay, so void clear. Add it over here. There we go. So now what are we needing to do? So what we do, let me find it, just make sure I've got it here. Where's my destructor and where's my clear function? Okay, so all I want to do is go ahead, all I need to do is go ahead and delete everything out, right? And when I'm all said and done then, just to make sure everything is nice and tidied up, head is going to point to null pointer again. Basically, just pretend like nothing ever happened. And so that's exactly the same thing between clear and a destructor. Everything's going to be erased, and it's going to be like nothing ever happened. Head is going to point to null pointer. The object can get destroyed, or it can just sit there empty, because basically you're just emptying the thing out. So what I need to do, just like before, is I need to iterate through. Equals head. All right, so then now what I can say is, make sure that, okay, while current does not equal null pointer, do stuff, right? So what do I want to do? I want to delete myself, right? However, the thing is I need to know where to go next, right? You're like, I need to know what the next pointer, because I can't delete the thing and then just say current, I wish I could, right? And then just say current equals current arrow next. Because if you do this, you're giving the operating system back that memory that you stole from it earlier. And once you do that, you no longer have access to it, because the operating system is now saying, nope, that's not yours. So this, it would be totally cool if I could do this, but I can't. So all I really have to do is kind of just set up a linked list node pointer. I'm just going to call it temp or next or whatever, and then just set that equal to current's next, because it's just a pointer. If I delete current, it's a pointer to newed up memory, but I didn't new up the memory. The operating system did not get back that newed up memory. So it's perfectly fine to do that. And then now I can just say current equals temp. And now I can do this and come around. So it's, you know, that one step operation that we wish we could do, we just kind of have to break it up into two steps and make sure we interweave everything so we do everything correctly. It's like, okay, oh, you're not a null pointer? Okay, get me your next, store it, delete what you got, and then now move over to whatever that is. And so I don't have to worry about 2 nodes or 3 nodes or 6 nodes, because if the next node is null pointer, it'll come back around and it'll fall through the while loop, because current is now equal to null pointer. So just to kind of come back here and just say, okay, a.clear. So print clear print exception thrown. Oh shoot, on the back. Oh, I forgot I put that. Where's my? Oh, it's only been a half hour. I should be able to do this without. Okay, so print the entire linked list, then clear it, then print it again, and see what we get. That's what I was trying for. Okay, so now this isn't working right. Did I just change the wrong thing? What in the heck? No, that's not wrong. Oh, hey. Well, I said this is the fun of things. I mean, I'm gonna get hit with these things just like you guys are gonna get hit with these things, right? So, okay, what did I do wrong, right? Okay, so let's just say, what did I do wrong? I know what I did wrong, so this is another. I can use this as a learning example. Everything's fine until I get to the clear, and then when I hit F10 and I try to print now, it will break on me, F10 through, and the reasoning for this is, let's go through the clear algorithm real quick. Go in here and say, okay, I'm going to go and delete every node. So current is, or sorry, head is pointing to head is pointing to the 1, but I'm going to delete it. I'm going to delete the first one, delete the next one, delete the next one, delete the next one. Let me fall through one more time, fall through. But now current is pointing to null, but head is still pointing to, oh my goodness, that's just garbage data. And just like I just warned you, and then I freaking did it. I said, I delete memory, I give it back to the operating system, but there's still a pointer to that thing. Head is still pointing to a memory location that a minute ago was perfectly fine, but now the operating system has claimed back. So to get around this, I have to make sure my head is put back to null pointer. Just forgot to do it. I talked about it, but I forgot to do it. So now everything should work out fine because it's deleting everything fine, but then later on when I go to use this thing and I go, hey, print everything out, which it goes to a memory location, it goes, and it goes, nope, there's nothing there. Operating system pitches a fit. So now when I say bring this back to null pointer, now that it's pointing to null pointer, it'll print nothing. And so now I print nothing. I'm all good to go. So there's my 1, 2, 3, 4, and then there's my line that prints nothing at all. Okay, so that covers everything I wanted to cover. Apologize again. This is like a sorry, not sorry kind of thing. Programmers do this stuff all the time, especially when you're talking, and I'm not a musician when it comes to talking and typing and thinking and all sorts of stuff. Don't do this in front of my computer every day of my life. So I think I've covered everything. I think I did a pretty good job doing it. If you have any questions, as always, please send an email to me at swardb@cod.edu. Send me a comment through YouTube if you want to. There is obviously more and more and more to cover. I give you guys this, there's a homework assignment to kind of take this and just go as far as you want, because the other videos show you all the functionality that linked list has, and it's definitely not trivial. There's a ton of stuff going on, and it is definitely more complex under the hood than vector and double-ended queue and stack and queue, because we are now duck-dodging our way around this thing. Data can go anywhere, memory can go anywhere. I'm newing, and there's all sorts of pointers going around everywhere. So anyway, thanks for sticking with me, and we'll see you next time.